All right, we are on to Unit 4. So we're going to start with Section 4.1, Classifying and Evaluating Polynomials. There will be quite a bit of vocabulary in this unit, but it will be important as it's going to carry on basically for most of the year. So starting down here with polynomials. So that is just all terms where exponents are whole numbers and coefficients are real numbers. All right, the degree of a polynomial is the largest exponent. And you would just say something like second degree, third degree, fourth degree, or whatever. So the leading coefficient is the number in front of the first term when a polynomial, is written in standard form. The constant term is the number without a variable. And then standard form, I'll just put terms written in descending order. Ooh, help if I spelled that correctly. And that's going to be, in other words, I'll just put this as well. Highest exponent term to the lowest. All right, so example number 1, it says take that polynomial and first write it in standard form. So f of x equals. So what you want to do is you want to look at your highest exponent and you want to take that term and put it first. So we'll go negative 2x cubed because 3 is the highest exponent. Then you take your next highest exponent, you go in descending order, so 3x squared, so go plus 3x squared, because that is the second highest exponent. And then last but not least is plus 4x. So that's just standard form, highest exponent all the way down to the lowest. Once you have your polynomial written in standard form, your leading coefficient is just the first number in front of your first term. So negative 2. And then the degree is going to be just 3, or you can write third degree if you want. It's just your highest exponent. And then, unfortunately, we have more vocab, so instead of just saying third degree, we have a name for that. So let's go ahead and just talk about each degree here. So if you have a polynomial that looks something like this, we call that a constant. There's no variables, it's just one number, that's it. A first degree, these are called linear. You spent a lot of time in Algebra 1, in fact, the whole semester in Algebra 1 dealing with linear polynomials, so something like 2x plus 3, linear, because your highest exponent is 1. Second degree, these are called quadratics, or a quadratic. These are the ones that we factor. We spent all second semester in Algebra 1 talking about. So something like x squared plus 3x minus 11. Third degree, these are called cubic. We're going to get into these quite a bit in this unit. It could be as basic as like 8x to the third minus 11. All that matters is your highest exponent is 3. So up here, this would technically be called, it is third degree, but a specific name for that would be cubic. Fourth degree, we call this quartic. Make sure to spell it right here, quartic. And something like x to the fourth. And you can get really crazy. That's a quartic right there, or you can add anything behind it as long as the exponent doesn't get any higher than 4. There would be a quartic, for example. Highest exponent is 4. And then anything 5th degree or higher, we just say it is to the nth degree. So x to whatever your highest exponent is. So, for example, if it was x to the 11th, well, let's write that a little better. If it's x to the 11th, we would say that is the 11th degree. That's just what we would name it. Okay, not only can we classify polynomials by degree, so the highest exponent, so like we said, this would be a cubic, we can also classify by how many terms it has. Now, the terms are generally separated by addition or subtraction. So let's take a look. If you only have one term, we call that a monomial. Now, here the exponent doesn't matter. Again, so you got to keep these separate. I could give you an example like 4x to the third. One term, monomial. It is a cubic if you're classifying by degree, but that's not what we're doing right now. Two terms we call a binomial. So something like 3x minus 7. There are 1, 2 terms because they are separated by addition or subtraction. So one term, another term. Trinomial would be third degree, or three terms, goodness. Trinomial. And these are kind of what we just got done factoring in the last unit. A lot of quadratic equations are trinomials, so I'll give you an example. X squared plus 7x plus 12. 1, 2, 3 terms. Trinomial. 4 terms, or really 5 or higher. Anything 4 and above, we just call these polynomials. An example, this will go like x to the 5th plus 6x cubed plus 4x minus 11. 1, 2, 3, 4 terms would be considered a polynomial, or anything more than that. So, example number 4, decide whether the function is a polynomial function. If it is, write it in standard form and state the degree. Classify degree by degree and classify by the number of terms and state the leading coefficient. So a lot of work for some of these. So letter A, this is not a polynomial because you cannot have negative exponents. If we go back up to the definition, all exponents are whole numbers. That means 0 and up. No fractions, no negative numbers. So this is not a polynomial. Example B. So you're looking for two things here. First of all, the coefficients are real numbers, so there's no imaginary, no imaginary, no imaginary. So we're good there. And all the exponents are whole numbers. 3, 4, and then there's x to the 0 technically here because there's no variable. So we are good to go. So this is a polynomial. So now we need to write it in standard form. So f of x equals, we'll start with our highest exponent term, positive x to the 4th, so we'll go x to the 4th. And my next highest would be minus 0.8x cubed, and then minus 5 is the only thing left. So that is in standard form. Now it says state its degree. That just means tell me what it is. So we would say this is a 4th degree. Classify by degree. So what do we call a 4th degree? A quartic. Classify by the number of terms. So I'm counting 1, 2, 3 terms. So we would call that a trinomial. And the leading coefficient, once you write it in standard form, is right here in front of my first term. If there's no number there, it's just 1. So there you go. I'm going to leave example C up to you. I will tell you that it is. I want you to fill in this information. So go standard form, state the degree, name it by degree, name it by number of terms, and give me the leading coefficient. So C is a yes. Even though you see a square root here, it is a real number. So go ahead and try to fill in the rest of the information. The last example here is what is the value of f of x equals, and it gives you the function when x equals -1. All you need to do is plug in, so take the function, replace all the x's with -1. So this over here means that we are bad color. We are evaluating the function at -1, so f of -1 equals, and then we'll take the rest of it, we'll go -5 times -1 to the 4th, minus 2 times -1 to the 3rd, minus 7 times -1 squared, plus 2 times -1 minus 3. So that's what it means when we're asking you to evaluate. Now you just need to simplify to one number. So -5 times -1 to the 4th is just 1. Minus 2 times -1 to the 3rd is still -1. Minus 7 times -1 squared is +1. Plus 2 times -1 minus 3. So I just took care of all the exponents right away. So now -5 plus 2 minus 7 minus 2 minus 3. So now I multiplied those two, those two, those two, and those two. And then if you just do the addition or subtraction, you will end up with -15 as a final answer. So there you go. Section 4.1, a lot of vocab. Naming polynomials by degree and terms can be kind of confusing, but we'll get some more practice here the rest of the week.